Right, hello YouTube, this is my first video, so I'm going to do a subject which everyone gets screwed up because they don't really understand it, which is logarithms. And I think everybody thinks it's really complicated, but the reason it's complicated is because it's just a different way of looking at index laws written in a different order. So I think the easiest way to understand logarithms work is by a simple numerical example, so it's kind of idiot proof. Log to base 10 of 100 is equal to 2. I just remember this kind of numerical example because you can sort of see where the bits go. This is because 10 squared is 100. It's always like this number called the base raised to this power is equal to this number here. So it kind of goes around in a kind of a triangle, like base power equals, like that. So this number to that power is equal to this number, and 10 squared is 100. Log to base 10 of 100 is 2. So that's the basic structure of a logarithm. And so if we can have logs to any base. So for example, log to base 3 of q is equal to 2 would be one question. So the value of q here. So you always go around base to this power is equal to that number. So 3 squared equals to q. Base power equals. So q would be 9 in this case. Let me try another one. Log to base say 2 of 8 is equal to w.
I know.
So we go, May, you're not supposed to talk in this. Okay. Base power equals, so 2 to the w is equal to 8. That's supposed to be my silent assistant here, but she's talking. So base to this power is equal to this number. Rearrange it to the more sort of the more familiar form that you're sort of used to looking at. So 2 to something is equal to 8. You sort of pretty common one. 2 cubed is 8, so w is 3. So log to base r of 4 is equal to half. So again, you just go base to this power is equal to that number. R to the half is equal to 4. So the square root of r is 4. So r is 4 squared, which is 16. So that's how the sort of structure of how a logarithm is set up. So you come to the that's with numbers, but the actual law of it, so to speak, is log to base a of x is equal to n. Can be rewritten as a to the power a to the power n is equal to x, and that's kind of like the basic definition of what a logarithm is. So logs are kind of related to indices the same way as so indices have got laws and logarithms have got laws, and the kind of way that you work with indices is you learn the laws and then you kind of work with them and you sort of understand how indices work. Well, logs are the same. They've got laws as well, which have got a particular form. So you learn the laws of logarithms, and then pretty soon you're able to sort of throw logarithms around in an equation. Right, before we go through the laws, I just want to go over natural logarithms, or what e is. So pi is a number that has a letter for it. It's a special number. So pi is 3.1415 blah blah blah. But e is also a number that has a letter for it. 2.71828 da 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 da. It goes on to infinity, doesn't repeat, it has no pattern. It's called a transcendental number, which it's a very sort of special number, and because there's no fraction for it, you use a letter to stand for it. And log to base. So a particular way of writing log to base e of x is written as ln x. So you find your ln x. So you find that your calculator has got two buttons on it. There'll be a log button, which when you write log x, there's an invisible 10, so it means log to base 10 of x. If you don't specify a base, it's base 10. Otherwise, you're going to have ln x on the calculator, which is e to the x. Or log to base e of x, rather. Log to base e of x. You also find that usually on a calculator buttons, the inverse of a particular operation is also on the same button. So the inverse of ln x is e to the x, and the inverse of log to base 10x is 10 to the power x.